All right, really quickly, I just want to put in a quick video to answer the question, when does a derivative not exist? The key is that a derivative is a limit. So a derivative doesn't exist when the limit doesn't exist. Keep in mind that we're talking about the limit as h goes to 0 of that difference quotient. Let me just silence my phone. My texts are blowing up right now. There we go. We're looking at that limit of a difference quotient as h goes to 0, so we want to focus on when the limit doesn't exist. So the limit will not exist in a couple of different ways. First, we could have that the one-sided limits don't match. Essentially, left and right aren't the same. This looks kind of funny graphically. When we look at things graphically, what we're going to notice is that we're looking at the slopes on the left and the right not matching up. So here, you can see that right at this point, 1, 0, the slope on the left looks like it's always going to be -1, and the slope on the right is always going to be +1. They're never going to match up in the middle, and so we can say that the derivative probably won't exist at 1. What that really means is that we're looking at these kinds of sharp corner spots. So let's go ahead and add that here. What that looks like are sharp corners. The second way that a limit might not exist is if we have some kind of discontinuity. So let me just put that on here first. That's going to end up basically covering the same kind of thing here. If we switch this graph to a different one that has some sort of a discontinuity on it, what you'll notice, let me put these points on here. Oh, wrong one. There we go. What you'll notice is that if we try and look at the slope at the point -1, again, the left and the right sides aren't going to be the same. We're going to have a hard time making the slope of the points. If you remember, we're dragging that point together where h is going to 0. As it gets really, really close, it's going to be way up here. So our slope is going to kind of be like this really steep line, but on the left side, it won't. So here, discontinuities are going to mess us up. The third thing is we can try and think of the slope of a tangent line not existing, and that's going to happen at vertical tangent lines. A vertical tangent line has an undefined slope, and so we'll say that the derivative doesn't exist there. And again, we can go back here and we can say that looks something like this. This is a weird looking function because it's not actually perfectly vertical here. If we zoom in, it'll look really vertical, but you can see that it slightly deviates away from the axis here. It's technically not vertical, it's just really, really steep. But when we zoom out like this, it looks like we've got this kind of oops, I don't want that. It looks like we've got this kind of a vertical tangent line right in the middle here. The slope of that vertical line will be undefined, so our derivative won't exist. So we've got 3 cases. We've got sharp corners, discontinuities, and vertical tangent lines. A lot of the ones that we're going to look at are going to be sharp corners and vertical tangent lines. But on those spots, we'll say that our derivative doesn't actually exist at that point. That's really all we've got for this. This is just a quick hitter to kind of shore that bit up. Hopefully that helps.